In this lesson, we'll look quickly at parallel and perpendicular vectors. It will continue on from scalar dot products. So we'll start with the understanding that the dot product of A and B with the product of the magnitudes, and then cos of the angle between. Now, it's important to understand that when A and B are perpendicular, that the angle between will be 90 degrees. Now, this is important because cos of 90 is equal to 0. So cos of 90 degrees is equal to 0, so therefore the dot product will be the product of the magnitudes, but multiplied by 0. And of course, when we multiply by 0, that we get 0. So for two perpendicular vectors, dot product will be 0. When we look at parallel, we're looking at an angle in between, which is 0 degrees. Again, that's important because cos of 0 degrees is 1. So the dot product of A and B, when parallel, will be the product of the magnitudes multiplied by 1. So that means the dot product will be the product of the magnitudes. So this is pretty important. We use these in proofs a fair bit. So it's important to remember when perpendicular, the dot product will be 0. And when parallel, the dot product will be the product of the magnitudes. Also, when we start looking at proofs with parallel, we use the understanding that if vector A is parallel to vector B, then A will be equal to some constant multiplied by vector B. So if there's a scalar multiple, or if they're exactly the same, then they will also be parallel. Okay, that's all the information you need for parallel and perpendicular vectors. We'll do a really simple example. Okay, so we're looking at the example if A is 2i plus 3j and B is negative 5i plus kj, determine the value of k if, so the first one's nice and easy, we're looking if A and B are perpendicular. So we're looking to show that the dot product of A and B is equal to 0. So 0 will be 2 multiplied by negative 5 plus 3 multiplied by k. So we got 0 is equal to negative 10 plus 3k. That's just a matter of isolating k. So 10 is equal to 3k, and therefore k is equal to 10 on 3. So when k is equal to 10 on 3, then vectors A and B will be perpendicular. When we look at B, we're looking for the dot product A and B. We're looking for A and B to be parallel. So we're looking for the dot product of A and B to equal the product of the magnitudes. So magnitude of A and magnitude of B. Or looking for A to be some constant multiple of B. Alright, so I'm going to go with the second approach because second approach makes more sense to me. We're saying 2i plus 3j will be some multiple of 5i plus kj. Okay, so this should be relatively easy if we expand this out and we compartmentalize. So we look at the I and the j separately. So 2i and 3j is equal to negative 5ni and k and j. Okay, so if we look at the I values, if we equate the I direction, then we get 2 is equal to negative 5n. So therefore, n is equal to negative 2 on 5. Now, if we equate the j direction, we get 3 is equal to kn. Now, we already know what n is, so 3 is equal to negative 2 on 5k. We can multiply across the 5 and divide the negative 2, and we can isolate k. So k is equal to 3 multiplied by 5 over negative 2. So k is equal to negative 15 on 2. And there we have it. So when A and B are perpendicular, we get a k value of 10 on 3, and when they're parallel, we get a k value of negative 15 on 2. All right, a really simple second example. Okay, so example 2 is nice and easy. We're trying to prove that A and B are perpendicular. So for that, we just have to show that the dot product is equal to 0. So A dot B will be 2 times 6 plus 3 times negative 4, and of course we get 12, take away 12, gives us 0. So therefore A is perpendicular to B. And when we look at part B, we're trying to show that C and D are parallel. So the easiest way to do that is show that D is some multiple of C. So D, if we take out a common factor of 3 here, is 3 lots of 5i plus 2j, which means that D is actually 3c. And so if D is equal to 3c, then it means that D is parallel to C. There we have it. That's parallel and perpendicular vectors.